Right then, January 2013, paper 1, hour and a half, non-calculator paper. First question, distance time graphs. Draw a distance time graph for Dan's journey. Dan leaves home at 8 o'clock. He drives 60 miles from home in the first 90 minutes. He stops for 30 minutes. And then he drives home at an average speed of 50 miles per hour. So, 60 miles in the first 90 minutes. Well, there's 60 miles. And that there is 90 minutes. So that's the first bit. He stops for half an hour. Well, 9:30 for 30 minutes gives me 10 o'clock. And now the bit that's just slightly trickier. Let's get a point. He then drives home at an average speed of 50 miles an hour. Well, at 10 o'clock then, by the time he gets to 11 o'clock, he's gone 50 miles. Or 60 down to 50 miles is 10 kilometres. So he's going to get to that point there. That's the way I look at it. So if I join this up to there, but then he's obviously going to carry on his journey all the way home, we're only going to get to there. Okay. So, does Dan get home in time for the start of a TV programme that starts at 11:30? Well, 11:30 is there. So, yep, he's going to make that. In fact, if that's 11:30, then these are going to happen 6s. He's going to get home at 11:12. So, Dan does get home by 11:30. But he will be home by 11:12. I'll be fine for that. He's even got 15 minutes to get the kettle on and have a cup of tea. The dotted line is one side of enlargement of a hexagon. Complete the enlarged hexagon. So the two lines we've got is this dotted line here, and then this one here is the same. Now I would say that's 2 right and 1 up. And this one here is 6 right and 3 up. So 2 right to 6 right we times by 3, 1 up to 3 up we times by 3. It's 3 times as big. So now we're just going to go around the hexagon, doing the same. So 1 down, 2 to the right, we're going to go 3 down and 6 to the right. Instead of 1 down, we're going to go 3 down, and then 2 right and 1 down is going to be 6 right and 3 down. And we can kind of see where the answer's taken us to. There. Scale factor. What is the scale factor of the enlargement? Well, just explained that. It's 3 times as big. So scale factor just means how much bigger is something. So scale factor 3. Solve 5x minus 9 equals 3x plus 11. So a bit of algebra. Right, and the way I always do these is I always try and get rid of the lowest amount of x that I've got first. So we've got 2 sides of the equal sign. You've got a left side and a right side. I'm going to get rid of our lowest amount of x's. So I've got 3x here, so I'm going to take 3x off of this side and take 3x off of that side. So 5x take 3x is 2x minus 9, and I've got rid of the 3x, so I'm just left with 11. There. Now I'm going to get rid of the minus 9 by adding 9 to that side, which means I've got to add 9 to that side also. 2x equals 11 add 9 is 20. And then hopefully then, if we divide them by 2, you get your answer, x equals 10. Now this question is going to come up, okay, so get your head around how to do that, because 3 marks really, which should be something you should be able to do comfortably. Number 4, a scooter is travelling at a constant speed of 75 kilometres an hour. The scooter travels at this speed for 20 minutes. How many kilometres has the scooter travelled in this time? Okay, so speed equals distance divided by time. And we're working out distance, so I cover that up, then I've got speed times by time. So I'm going to times the speed by the time. However, before that, we've just got to be careful. The speed is 75 kilometres an hour, yet the time is 20 minutes. So I need to change that into hours. So 20 minutes is 1/3 of an hour. Okay, the reason being is 20 over 60 simplifies to 1 over 3. So now, distance equals speed times time. So for us, that is speed 75 times by the time, which is a third of an hour. Wow, if we times something by a third, that means we're going to do a third of it, and a third of 75 is 25, so it's 25 kilometres is our answer for that one. The speed limit is 50 miles an hour. Is the scooter travelling faster or slower than the speed limit? Okay, so one fact that we need to know is that 1 mile is equivalent to 1.6 kilometres. That's not going to be given to us, you need to know that. Okay, so if I know that one, then I can then work out what 50 miles is. So 50 miles is 1.6 times 50. So, wow, if I'm going to times by 50, I'll times by 10 first to give me 16, and 16 times 5 is 80. Okay, so the speed limit is 80 kilometres an hour. Well, the scooter is going 75 kilometres an hour. So he is going slower. Than the speed limit. I think that working out is fine. Okay, do need to know this though. That's not going to be given, so you need to know that one. 1 mile is approximately 1.6 kilometres. Number 5, complete this table. Okay, so 3 to the power of 0 is 1, anything to the power of 0 is 1, 3 to the power of 1 is 3, 3 squared is 9, 3 cubed is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. 3 to the 4 is 3 times 3 times 3 times 3, which is going to be 27 times 3, which is going to be 81. And then we times 3 will be the 243, and times 3 will be 729, and so on. So, now I've got that. It's telling me that 729 times 2187 equals this. And that equals x. Use your table to work out the values. Okay, well 729 is the same as 3 to the power of 6. And 2187 is the same as 3 to the power of 7. And whenever we are multiplying the powers, we add the little numbers together. So 6 add 7 is 13. Okay, so this number here is 3 to the power of 13. X has to be 13. And then we're there. Use the table or otherwise to work out 2187 divided by 9. I mean, if you're not happy, you could just do long division on that if you want to. Give your answer as a power of 3. But if we look for 2187, then that is 3 to the power of 7, and 9 is 3 squared. So essentially, this here is equal to 3 to the power of 7 divided by 3 squared. It's a bit fiddly. Okay, so 3 to the 7 divided by 3 squared. Now, if we are dividing powers, and the base is the same, then we just take them away. So that is going to give us 3 to the power of 5. Okay, now if you want to, you could do the sum 2187 divided by 9, which would give you 243, which is then 3 to the power of 5. It would be fine. Number 6, the grid follows 2 rules. Rule 1, the sums of each row are equal. 2 rows go this way, across from left to right horizontally. So 117 and 170 the same, and the products of each column are equal. So sums means if I add this way, add the rows, none are the same. Product means multiply. So 5 times 96, 32 times 15, and so on are the same. The grid below follows the same rules. Work out the missing numbers. That's quite tricky. Okay, so 60 and 2 numbers times gives 60, so we could have 1 and 60, could have 2 and 30, could have 3 and 20, could have 4 and 15, could have 5 and 12, could have 6 and 10. Any of these numbers could go into here. The times to give that. Okay, I can't see any other way than just going for it. So I'm going to go for 5 in there, and 12 in there. Now I know that these two have got to be 60. In fact, okay. I'm going to go back a step and just delete them two off. Okay, so I know these two numbers are 60, and this number here times 5 is 60, so that number at the top there is going to have to be 12, because 12 times 5 is 60, and that one there is going to have to be 10, because 10 times 6 is equal to 60. Now and then one of these pairs of numbers here is going to go, and they're going to have to make these numbers add up the same. So this is 22 here, and that's 11. So this number here has to be 11 more than this number here. Well, that looks like 4 and 15 to me. Because if I have 15 here and 4 there, I'm going to catch the 11 up. So looking on the top, first of all, 4 times 15 is 60. 4 add 12 is 16, add 10 is 26. And 15 add 5 is 20, add 6 is 26 as well. And then we're there. It's quite a tricky question. Alright, but hopefully you'd have got there. The rule for continuing a sequence is double the previous term and add 5. The third term is 27, work out the first term. I'm going to get myself some boxes going on here, so... Okay, so I know that if I double this number and add 5 I get to that one, and if I double this number and add 5 I get to this one. So if we're going to go backwards, we need to do the opposite of that. So instead of doubling and add 5, I'm going to take 5 and half it. Take 5 off 27 is 22, and then half it is 11. I can check that works because double that is 22, add 5 is 27. Take 5 off 11 is 6, and half of that is 3. And check to go back, 3 doubled is 6, add 5 is 11. So my first term is going to be the number 3. Alright, I guess in terms of working out for that one, you could say what you're doing. So you could say minus 5, then divide by 2. Although I don't think that would be necessary to get the full marks on that one. I think what I did before would be fine. Nth term of this sequence. Okay, so for the nth term of a sequence, the first job is we need to work out what it's going up by each time. So it goes up by 4 each time. Now this means that the sequence is somehow linked to the 4 times table, because it goes up by 4 each time, as does the 4 times table. So we start by putting 4n, because that means 4 times a number that we don't know, the 4 times table. And now how do I get from the 4 times table to these numbers here? Well, it's the same as saying how do I get from 4 to 6. And to get from 4 to 6, I add 2. So my answer is 4n plus 2. Work out the area of a semicircle of radius 6 centimeters. Give your answer in terms of pi. Area of a pi. Well, let's put them both down so you've got them both. And that's an ugly looking symbol. I'm going to go for the other one. There we go. Okay, so there are your rules for circles. Circumference is pi times the diameter, and area is pi times the radius squared. You need to know them rules. Handy way to remember them: cherry pie is delicious, apple pies are too. Because we all love a bit of apple pie, right? But you can't knock cherry pie either. So, the area of this semicircle then, or we're going to work out the area of the whole circle and then half it. So the area is pi times the radius squared. Well, in this case, pi is 6. So 6 squared is 36. So the area of the whole circle is 36 pi. So area of semicircle is half of that, which is going to be 18 pi. So 18 pi is there. Oh, let's just say of semicircle. So it's 18 pi anyway. Number 9. Show the inequality x is greater than minus 2 on the number line. So, perfect. It's a bit on the big side actually. Okay, so x is greater than minus 2. Well, minus 2 is there. So if x is bigger than minus 2, then it's somewhere in this area here. Now the key to this is just checking to make sure whether you coloured it or not. X is greater than minus 2, so we leave it empty. If x is greater than or equal to minus 2, i.e. can be minus 2, then we then have to colour in the little circle that we got there. Okay, but because it's greater than minus 2, we don't need to colour in. Solve the inequality. 3x plus 5 is greater than 11. So to do that, I mean, essentially you just ignore this less than or equal to sign and treat it like an equal sign when solving equations. So first job is to take 5 off both sides, so we get 3x. There is less than or equal to. I've just got to find my little symbol. No, not that one. And if I take 5 off of there, I've got to take 5 off there, so 11 take 5 is 6. And then I'm going to divide by 3, which is going to tell me that x is less than or equal to 2. So there's my answer on that one. Now I'm wary on this one that there's a little star on the question at some point, so I think I'm going to add in exactly what I've done on these steps here. So I minus 5 on this one, so minus 5 there, which meant that minus 5 there, and then I divided by 3. So a little divide by symbol, divide by 3. On the next line, to get that x is less than or equal to 2. Number 10. 5 whole numbers are written in order. The mean and median of the 5 numbers are the same. Work out the values of x and y. Okay, so first of all, what could the median be? I'm going to make a little note of that. So median could be, it's a bit on the big side, well, it could be 7, because then it would still be in the middle. Or it could be 8, it could be 9, it could be 10, or 11. Okay, it can't be bigger than 11 because then that'll be there. So that's what the median could be, is that. So now trying to work out what the number could be. Well, 4 add 7 is 11, add 11 is 22. The mean is divided by 5, then the mean is going to be the sum of them over 5, and the median has to be the same as that. So x is equal to x is equal to I'm going to have a look into that one and then find out, because I'm having a bit of a mental block on that one. I'll come back to you and have a look. Number 11. The radius r of a cylinder is 10 centimeters. The height is 4 centimeters. The volume of the cylinder is v equals pi r squared h. Work out the volume of the cylinder. So our rule is v equals h pi r squared h. So what we're going to do is we're going to put our numbers into that. So the radius is 10, so pi times 10 squared times by the height, which is 4. Now it's also told us that pi is equal to 3.1, so I'm going to pop that into there as 3.1 there. So now working this out with our calculator, well, 10 squared is 100. Is 100. Now what can I do fairly easily? Well, I can do 3.1 times 100 quite easily. 3.1 times 10 is 31, so that's 310. And now I've got to times that by 4. And you can do this in grid method if you need to, but however you do it, you should get is 1240. And that is your answer, 1240. Number 12. The diagram shows the plan of a room and new sockets to be fitted onto one of the walls. It must be equal distance from the 2 arrow sockets and at least half a metre from the fireplace. Need a compass. Hopefully this will work. Not too bad, I think we can do that. So if it's equal distance from the 2 arrow sockets, it's not going to let me do it. Right, I'm afraid you have to have a look at that one yourselves and come and find me if you don't know how to do it. Essentially, you want to be doing a perpendicular bisector between these 2 points. So an arc, and then you get yourself a line through the middle. And then with a ruler, half a metre from the fireplace, we can measure half a metre there, half a metre there, and half a metre there. And we can add in a sort of, a bit like you get in football, like a D shape. And then we can then find where the answer could be. Alright. Number 13. Show that xy plus 6 minus xy plus 4 is equivalent to 2 lots of 3x minus 2. So we can treat this as two sides, and treat this as the left hand side, and then do the right hand side afterwards. So left hand side. xy plus 6, actually I'll write out in full because it's a star question. So I might as well put all the information on that we can. So that's the same as xy plus 6x minus xy plus 4. Careful. So xy plus 6, but then minus xy, and then minus the positive 4 makes that negative 4. So xy minus xy is 0xy, so I'm left with 6x minus 4. So that's the left hand side. I can do the right hand side. Well, the right hand side is 2 bracket 3x minus 2. So 2 lots of 3x is 6x, and 2 lots of 2 is 4. So they are equivalent, or are the same, however you want to put it. (14) 2x plus 3 over 4 minus 3x minus 3 over 2 is equal to 2. Okay, so whenever we've got fractions in algebra, we want to times everything by your denominators. So I'm going to start by timesing everything by 4, and then I'm going to times everything by 2 afterwards. Okay, so if I times this term by 4, then I just get left with 2x plus 3. If I times this term by 4, then it's the same as just timesing the top numbers by 4. And that stays over 2. And then this term times 4, or 2 times 4, is 8. So I can get to that. And now I'm going to times everything by 2. So I times this term by 2, I get 2 lots of 2x plus 3. And if I times this term by 2 here, then I just lose the 2. And 8 times 2, that's crazy, it's 16. So a bit of hard work to get rid of the fractions, but once you've got rid of the fractions, then you're just left with an equation to solve, which you should be able to do. 2 lots of 2x is 4x, 2 lots of 3 is 6. Careful with the minus sign that we've got here. So 4 lots of 3x is 12x, but minus 4 times minus 3 is positive 12. So expand your brackets first. Now simplify. 4x minus 12x is minus 8x. 6 plus 12 is 18, and that equals 16. I want to get rid of the plus 18 off this side, so I'm going to take 18 off there and 18 off there. I'm left with minus 8x equals minus 2. And now I'm going to divide by minus 8. So minus 2 divided by minus 8. Well, a negative divided by a negative is positive, and 2 divided by 8 is the same as a quarter. So it's a positive a quarter, or I guess if you like decimals, x can be 0.25. Alright. Number 15. How are we doing for time? Nearly done. So a school has 400 boys and 500 girls. The probability that a boy is vegetarian is 0.1. Probability that a girl is vegetarian is 0.2. Estimate the total number of vegetarians in the school. Okay, so I'll go boys first. Boys is 0.1 times by how many boys we got, which is 400. So to do that, well, 0.1 times 100 is 10, so 400 will be 40. And do the same for girls. Girls is 0.2, and there are 500 of them. Well, 2 times 100 is 20, times 5 is 100. So there's 100 girls and 40 boys, so I make that 140 altogether. There are 10 prefects in the school. 4 of the prefects are vegetarian. 2 of the prefects are chosen at random to have lunch with a visitor, so that probably they're both vegetarian. So probability both vegetarian equals, well, the probability of one of them being vegetarian, well, that's 4 out of 10. Multiply the probability of the second one being vegetarian, which is going to be, well, the first one's been chosen now, so there's 3 vegetarians left out of 9. So now multiplying them, 4 times 3 is 12 over 90. And if I simplify that by dividing both by 6, I get 2 out of 15. So there's your answer. Number 16. The cone below has radius 3, slant height L, and it tells the total surface area, including the base 24 pi. Work out the length of L. So this rule here is given to us in the formula page at the front. The total surface area is what we're after. Well, we've got the curved surface area, so then to get the total surface area we just add the base on as well. The base of a circle, which is pi r squared. So total surface area is equal to pi r squared, the area of the circle, plus the curved surface area, which is pi RL. So there's our rule. Now we're going to put in the numbers that we know. So the total surface area we know is 24 pi. Centimetres squared. And then for this bit here, well, we know that the radius is equal to 3. So 3 squared is 9. So that's going to be 9 pi. And the radius here is 3. So 3 times pi times by L. Right, the next job is to divide everything by pi. So 24 divided by pi is 24. 9 pi divided by pi is 9. And 3 pi L divided by pi is going to be 3L. Now we've got a bit of algebra to solve. If we take 9 off of here, we can take 9 off of there. So 15 is equal to 3 lots of L. And then finally, if I divide by 3, I'm going to get L is equal to 5. So there's your answer. Alright. Number 17. Show that R sets happy days. So, show that root 75 could be written as 5 root 3. Right, to do this, we're looking for a square number that goes into 75. Well, that will be 25. And 25 times 3 is 75. So, Now to work it out, square root of 25 is 5, so your answer is 5 root 3. Rationalise the denominator and simplify. Okay. So if we want to rationalise the denominator, we multiply the top and the bottom by the surd that we've got. So in this case is root 3. So I times the top and bottom by root 3 over root 3. So for us then, that is going to be, on the top, 6 times root 3, well that's 6 root 3. And on the bottom we've got root 3 times root 3. Now root 3 times root 3 is the same as root 9, and root 9 is the same as 3. So that's that there. And now finally, 6 divided by 3 is equal to 2. So our answer is going to be 2 root 3. So work out the mean of the three numbers. Root 75, and 6 over root 3. Okay, well, the key to this is noticing that these numbers here are the same numbers that we've just been working with. So actually, root 75 is 5 root 3, root 75 is 5 root 3, and 6 over root 3 is 2 root 3. So we're going to add them together. 5 root 3 plus 5 root 3 plus 2 root 3. And then because there is 3 numbers there, I'm going to divide it by 3. So how many root 3s have I got? 5, add 5 is 10, add 2 is 12. So I've got 12 root 3, which I'm going to divide by 3. And 12 divided by 3 is 3. So that's going to be 4 root 3 as our answer. Simplify fully. 9x squared minus 1, and so on. So there's a couple of things we need to do here. Firstly, you need to know that when you're dividing fractions, you flip your second one over, so you make the reciprocal of the second fraction and you change it to a multiplying. And then we need to do some factorising on these as well. So we'll do the division bit first. So the first fraction stays the same, 9x squared minus 1 over 3x squared plus 2x minus 1 . So the first one stays the same. Change the divide to times, and then we flip it over. So them two are the same. Now then we need to factorise both of these things. So we'll do that over here. Nine x squared minus 1. That's quadratic, so it's going to have to go into double brackets. Now a number times itself is 9, it's going to be 3, so it's going to be 3x there, and 3x there. And because we've got minus 1 here, what two numbers get multiplied to get minus 1? Well, it can only be minus 1 and plus 1. So I've got that. That should be fine. And now I've got to do the other one. So 3x plus 2x minus 1. Same thing. Going to put this into double brackets. We're going to have 3x and x there to get the 3x squared. And we've got ourselves, well, plus 1 and minus 1 is the only way to get 1. Just got to be careful we do that the right way around. So if I have plus 1 there, then it's going to give me 3x. And minus 1 there is going to take an x away. So I'm going to get to that point there. So now I've got that, I can put that into the sum we're trying to work out. 9x squared minus 1 is equal to that. And 3x squared plus 2x minus 1 is equal to that. So that's that there. I've still got this going on with the other fraction. So now if you're multiplying fractions, you just multiply the top together and the bottom together. So I'm just going to combine them together. So I get to there. And now to simplify it, we just get rid of anything that's the same. So 3x minus 1, 3x minus 1 is the same. I've got 3x plus 1 and 3x plus 1 the same. So my answer is x minus 2 over x plus 1. Winner. Last one, I think. 19. The histogram represents the birth masses of 500 mice. Work out the number of mice with birth masses below 10 grams. Okay, I think what we're going to do on this one is look at, we need to somehow work out what the scale here represents somehow, and all I know is that altogether these bars add up to 500 altogether. So, if I imagine stacking all of these bars on top of each other, then how many little squares would it go up to altogether? So it's 3 little squares in that bit, and another 3 in that bit will be 6, 9, 12 high on that one of the little squares, and then with 5, 8 here, so that's 20, and 8 there is 28, and then 11 there, and 11 there's another 22, so that's 50 altogether, and then this one goes up 23, so that's 73 little squares altogether, 3 strips same as that, and then this one here is 19, so that's 92 altogether, and then it goes up 2, 4, 6, 8, so it goes up 100 squares. So if I had strips this width going all the way up, it would go up 100 places. Okay, now each square then, or each square high for that strip is going to have to represent 5, because 500 divided by 100 equals 5. Okay, so that's the first bit, which means that each little square there represents 5, so that is going to have to be 25. And then 50. And 75. No, that's not right. Let's go with it and see. That's 100. That's 150. So now to work out the number of mice birth masses below 100, or frequency, here's the frequency density times class width. So for us, that is going to be, the frequency density is 15, times by the width, which from 6 to 10 is 4, which means the frequency for mice under 10 grams is 60. And there we have it. There's our answer. I think that's correct. I'll have to check that one though, just to make sure. But I think we're there. The key is to try and work out what each bar is. So work out what the frequency density scale is, and once you know that, then you can then use your rule to work out your answer. Sorted.